students, this is Miss Edwards and this is our lesson on sequences and patterns. Make sure you have your math notebook in front of you as you're going to copy down some notes. The first thing I want you to copy down is this statement right here. A sequence is an ordered set of numbers or terms. Every sequence has a rule or pattern. It's our job to figure out what the pattern is and what terms come next in a sequence. Let's look at this first example. Find the next three terms in the following sequence. We have 2, 4, 8, 16, 32, and we're trying to figure out the rest. Well, let's start writing down the difference between each of these numbers. I'm going to start by looking at 2 and 4, and I'm going to draw a little bridge between them to keep track of my work. So 2 and 4, well, I can get from 2 to 4 by either adding 2 or I could multiply by 2. Either way, 2 plus 2 equals 4 or 2 times 2 equals 4. Let's look at my next bridge. If I connect 4 and 8, I can think of it as adding 4 or I can think of it as multiplying by 2. Let's continue to my next set of numbers. I can make a bridge between 8 and 16. I can think of it as adding 8 or I can think of it as multiplying by 2. My last connection between 16 and 32, I can think of this as adding 16, or I can think of this as multiplying by 2. Well, now I have to figure out what the next three numbers are. So if I just look at my pattern from my addition table, I can see the difference between each of these set of numbers. 2, 4, 8, 16. These are each going up by a multiple of 2. However, if I just look at my bottom pattern down here, it's pretty consistent. Each time I'm multiplying by 2. Well, for me, that's the easier way to think about it. So in order for me to bridge 32 to my next number, I'm just going to multiply by 2. So I'm going to look at 32 and say 32 multiplied by 2, which gives me 64. Let's go back and see if we can use our addition pattern to also come up with the next term. I know that 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. To continue this pattern, I would need to multiply 16 times 2, which would give me 32, and add that to my addition pattern. If I take this and continue my addition pattern, I would go back to the term that I stopped at, and I would say 32 plus 32, which also gives me 64. So either way, I come up with the next correct term in the sequence. Now that we understand the pattern or the rule, let's figure out the last two terms. I'm going to move this over here so I have more space. And I'm going to write the next two terms. So continuing my pattern, 64 was my next term. I need to take that and multiply it by 2. 64 times 2. This will give me 128. I'll write that up here as the next term in my sequence. And then take that and multiply it again, 128, by my pattern of 2. And that term will be 256, which I would again write up in my sequence. So my answer for the next three terms is going to be 64, 128, and 256. Let's look at another example and try and find another pattern or rule that we can follow. Here I see that I have 27, 9, 3. I'm missing two numbers in the middle, and then I have some fractions on this end. Just based on this information, I know that I'm going to be decreasing because I have a large number at the beginning and a very small number at the end. So I'm thinking either subtraction or division. Let's start with my first bridge. Starting at 27 and going to 9, I know that 27 divided by 3 will give me 9. let's look at my next bridge. 9 to 3. Well, I also know that 9 divided by 3 will give me 3. Before I go ahead and solve for these missing values, let's look at my tiny fractions on this end. I know that multiplying and dividing by fractions are related, and I need to remember that when I divide a fraction, it's the same thing as multiplying by the inverse. So 1/9 divided by 3 is the same as 1/9 multiplied by 1/3. If I think of it that way, I can clearly see that each of these bridges also divide by 3, which means my initial pattern checks out. Now we just need to solve for those two question marks in the middle. Looking at my previous term, 3 divided by 3 equals 1. If I plug that in up here, I need that to solve for the last term. 1 divided by 3 equals 1/3. And I can plug that into the second question mark. Let's look at this final example. Sometimes rules can have more than one pattern. Let's start making our bridges here. Starting at 10 and going to 8, I see that I'm subtracting by 2. Let's look at my next bridge. Starting at 8 and going to 11, I'm increasing by 3. Interesting. As I keep going, 11 to 9, decrease by 2. Well, I'm trying to solve for these missing values, so let me skip to the end. If I bridge between 11 and 14, I can see that I'm increasing by 3. And if I bridge between 14 and 12, I can see that I'm decreasing by 2. This tells me that I actually have two different patterns in this sequence. I first subtract by 2, and then I add 3 to each term. So if I start at 9, where we left off, I look at my pattern and say, the last thing we did was subtract by 2. So the next thing I need to do is add 3. 9 plus 3 will give me 12. If I subtract 2 from 12, I'll get 10. And if I add 3 to 10, I'll get 13. Now bridging between 13 and 11 should continue the sequence. So 13 minus 2 will give me 11. This pattern checks out.